Let's start with the last talk. We'll have Alberto Paro from Big Data Technologies, and we speak about Scala.js, so good luck. Thank you.
Thank you. Okay, typically we are working on Scala, we are working on JVM, but there are other possibilities that we can explore. One of these is using Scala for web developing at front-end side. How many people are using Scala.js or are doing front web development here? Scala.js? 0, okay. Okay. First about me, I'm engineering. I'm working, do a lot of consulting. I write some book about Elasticsearch. Mainly, I develop big application in Scala, and now I'm using Scala.js for the front end because reduce much more the time required to deploy the application and create a big application. Why Scala.js? Developing web application is a very complex work because there are a lot of problems in developing application. There is the complexity of web browsers. There is also the complexity of JavaScript because it's not strong typed. There are a lot of errors. Also, there are some strange behavior of JavaScript. Yes, a lot of language defects, but the defects depends of the age of the language because when it was born, it was not created and developed for modern application development. It's more also the complexity of the application is changed a lot. Now we deploy mainly SPA, single page application. That means there is not a lot of pages that we deliver on the client side, but we deliver the first time the HTML, a big block of JavaScript and assets, and then the web browser manage all the stuff. Either are very good, but there are a lot of problems because refactory in JavaScript is very hard. It's very hard in Scala. It's work very well in Java, but in JavaScript there are a lot of problems. Typically because sometimes there is a lot of literals that can be used as variable and so on. So it's very complex. Also, if your project is very large, this is multiplying complexity. So a lot of languages are born for reduce the complexity of JavaScript. CoffeeScript is one of the most famous. Also, we have a lot of many languages. There are 100 languages that now you can write and are translated in JavaScript. CoffeeScripts, TypeScripts, and so on. There are some links when you can go. Scala.js is a compiler that used to convert your Scala code to an equivalent JavaScript code. So you write traditionally standard Scala code, and you can use it on your front end. This is wonderful because everything is Scala. The compile manage the rest of the complexity. For example, in a few months we'll migrate from ECMA 5 to ECMA 6 for the JavaScript language. Also, there are a lot of problems related to migration of the frameworks. AngularJS 2 will be very different from today Angular, and so on. Also, Scala.js allows you to use a Scala macro in your code, so there are a lot of advantages. It's easy to interoperability use with JavaScript because at the end the compiler produces standard JavaScript. Also, it's wonderful because there is a lot of stuff that is able to produce very small code because use the Google Closure compiler to reduce the code. Also, the debugging is very good because we have source map. Source map allows us to use the web browser debugger, but we navigate in Scala code, so it's not too complex use it. Scala.js code can call easily JavaScript and also the opposite. So if you need to write code for example, for Node.js, you can write Scala code and compile for JavaScript. This is possible because there is a pipeline that is able to compile your Scala code for the JVM in a traditional way. Also, there is a plugin that is enabled in SBT that allow you to create an intermediary representation of your code. We have seen with Martin this morning that in future this kind of transcoding will be integrated much more in a Scala process. When we have this intermediate representation of JavaScript, when we need to deliver the final JavaScript, we have a fast opt that is a very big file that fill up all your code in one single file that is usually very huge. But for production use, there is the full opt that remove all the code that is not used, so you can have a very small file to deliver it to the client. There are a lot of problems when we deliver web application, mainly because you are unable to reuse the code from the server and the client. I write my case class, I write my models, but I am unable to use them on the client side because I need to rewrite them. Also, algorithms, typically I write them in the backend, and I need to rewrite them for the client in JavaScript, and so on. With Scala.js, you can write models, algorithms, only in Scala and using the front end and in the back end without changing the code. Also, a good part of the Scala.js ecosystem is to reduce a lot of problems. Problems related the sharing the information between your server, your client. We'll see then a library that do the hard stuff automatically. So you need not to write a serializer for your REST services and the serializer for it, and so on. Also, typically when you use web developer, the Ajax call have no type check. So typically when your models from client and server are different, you have big problems in debugging. JavaScript issue we have already discussed. People cannot sleep if they forget some var and do pollution of global JavaScript namespace. Also, there are strange behavior for no expert in JavaScript. For example, this kind of representation, parse to int of array, in JavaScript, the result will be this one. People that are, this is a very, there are very strange behavior of the language that one must have some expert to manage them, because the correct representation for this map function will be this one. So, so on. The idea of Scala.js is we can create the application in only one language. We don't need to learn also and master JavaScript, so reduce the time and also the skill required in a company. Also, strong typing from RPC calls, so reduce the problem client-server communication. eliminating this problem gives you a wonderful boost. We see AutoWire library to do this then. Scala type safe, so when you compile your code for JavaScript, your code are seldom broke. Okay, for example, if you have this kind of example, I use L and on I for a JavaScript function. Compile time checking says, oh, there is an error because don't exist get element by LD. So this is wonderful. Also standard behavior for our code. This one will be work, okay. But we have also some difference. We are now running our code in JVM, so we are not the JVM under the hood. We have our browsers. Our browser usually runs JavaScript, so we have no JavaScript machine on the hood, but we have the JavaScript virtual machine. JavaScript virtual machine have different behavior regarding exception. For example, division by zero is no exception, is none in JavaScript. Also, the type checking for number in JavaScript there is not the concept of int, long, double, float. Everything is number. So when you check, for example, the number class, it depends of the numerical instance. The concept of scala unit is undefined in JavaScript. Also, we need to pay attention to JavaScript regular expression that are different from Java regular expression. Typically, every language defines their specific changing in regular expression, so we need to pay attention. When we want to create a typically Scala.js or cross-platform JVM, AJS project is quite simple. We can do simply using SBT. We define a single multi-target object. The big difference from traditional one is that we have cross-project. Typically, when we have JVM code, we have only project, so the only main difference is this one. Then we can define JVM setting and JS settings. JVM settings are related to the Java Virtual Machine settings. We can provide the library that are used in our JVM code, and JS setting that where we store our settings related for the JavaScript part. In the middle, we can use libraries that are available in both the worlds. For example, we have defined Scala tags that is available both for JVM and JS. We used a special operator. We have 3 modules. The 3 modules notation says that these dependencies used both in JVM and JS. Automatically, the plugin defines 2 sub-projects, the JVM project and the JS project. The structure is quite similar to the traditional one. When we have the shared source, when we put the code that we use in both JVM and JS, and JVM source directory we put the JVM part, and JS the JavaScript part. Now I show you some library that can be very useful to speed up the development of Scala.js. They are part of Scala.js system because they provide very wonderful utilities function. For example, AutoWire resolve a big problem, the RFC communication from the client and the server. When you need an RPC call, you need to serialize from the front end, interpret the code on your JSON, for example, in the backend, extract the object, do your processing, and deserialize outside the result. So you have a lot of stuff that you can do. AutoWire allow you to define a trait that you in your shared code, and you share your signature of the code from in the front end and in the back end. So the callback is thread safe both in server side and client side. This allows you to create client calls that are type safe. For example, in shared interface, we define an API that do a simple add operation, and then at the server side, we can create our implementation. This is implementation, typically it's in JVM, so we can use everything available in JVM. The inference of the type, we are with the signature, and in the client side, this code is executed on your browser, and we have the result of your call. Serializing the numbers, sending on the client, deserialize the answer from the server, is everything done automatically from AutoWire. AutoWire so you to create a very fast callback from client and server without writing a lot of code. Typically, if you need to do this one with spray or play, you need to write a very huge amount of code, because you need to write a server side the root, the serialization, the deserialization of the object, and so on. And in the client part is the same. We will talk about RPC, but another important part is the possibility to have strong typed HTML. HTML syntax during the age started as a markup language from XML, GSML, but when the time passed, the syntax became very, very ugly. For example, this is a big problem when browsers such as Internet Explorer 4 and similar allow broken XML and broken code to be executed, so the quality of the XML code was very bad. This library, available on JVM and JS, allow you to write your HTML in Scala, then the system is very fast to produce the code in HTML and convert them. Main advantage of using this kind of library that you have, because everything is in Scala, you have code completion, you have suggesting if you create bad text, you have autocomplete, you have error highlighting if you don't close your tags, also your inline documentation, and so on. Mainly, in this way, you are able to create a wonderful, strong typed HTML that is correctly written. Also, for example, this kind is a traditionally fragment of Scala tags written in Scala that is translated in the same code in HTML. So you can write your web page in Scala. Initially, it can be seem some quite odd writing HTML in Scala, but if you think that you can use all the power of the Scala language, you can create traits for generating your code. You can create for example, function, they inject complex table in your code. You can create, for example, table that extend a trait that generate other code. It's wonderful to have a wonderful way to write your code in Scala. Talking about JavaScript, there are a lot of with the previews, Scala tags can be used, for example, also in Play, in the templates, or in your web services because it's very light. But we have also need to create complex application. Today, world complex web applications are done with different kinds of frameworks. The most famous one is Angular.js because it is the first one to give a wonderful way to synchronize your model with your HTML. So was the first to be see as the new future for the web development. Angular have different. I have two different Scala.js binding that are used. Scala.js Angular is the first one to be born because it's very old. I can see there about 8 months at least that I use it. It provides you the possibility of define Angular.js code in Scala. For example, register classing as config or creating a singleton object using Scala code. Everything is Scala code, so you can define Angular services, controllers, directive, filters completely in Scala. So there is no problem, for example, using complex algorithms in these kinds of objects. Also wrap energy roots. Typically when you do web development in a single page application, you need to create a way to route in your page the fragments. For example, you click on a link that is the menu. You need to change the main content part of the page. So you need routes. The Scala.js Angular provide you with ng routes. That is one of the most used root system in Scala.js. The code is very simple because the macro annotation for inject table allow you to write code in very poor way. There is the facade for every service and controllers available in Angular.js, so you can write your code efficient in complete safe way. Another wrapping for Angular.js, Angular.js Angulate, that is very similar to the first one. You also provide much more facade on core API. It's a new one, but the authors are very fast, are working very fast. They provide a lot of macro to do typically things that people done in Angular.js. So your code is much more good to read. For example, you can create controller in such way. The controller in Angular.js is a fragment of the page that have static behavior. For example, if I have a fragment with a count, typically I put the 2 buttons for increase and decrease a value and so on. This is an example of controller. And this is the counterpart, is the template used for using the controller. So we can recall the controller where we already defined, and we can register the button click for decrease and increase the value. Angular is a wonderful framework, but it's not so Scala way of do the things, because you need to separate, for example, the templates from your Scala code. So you separate the template for your Scala code. In the middle, you can put some errors. So it's not so good to be used. Another solution that is wonderful to use with Scala.js is using React. React started to be very famous in the last month, but it's wonderful and everyone loves it because different way. The first, the code is very clear. So everything is a web part, is a web component. So you can give a simple divided dimper approach. So you create a component for your menu, a component for your taskbar, a component for your drop-down menu of the user, and so on. You have different fragments that there are components, they are different life, they are separated, and they can communicate between them with signals. Your app is predictable, it's very clear, you can create a simple data flow, because you have this kind of separation, and the user can fast detect where the problem is. Because typically when you have a very complex web application and you have some problem with the roots or other things, it's very hard to detect where the problem is. Also, it's very fast. React was one of the first libraries to use the virtual DOM. What's virtual DOM? Virtual DOM allows you to have a better experience because React keep your web page and your component representation in memory with a lot of ID. When you change the behavior of your object, the system don't recreate all the page. Typically, React.js, Flick, and a lot of applications create a Flick effect. They replace only the HTML fragments that change, so it's very fast. Also, there are different advantages, but I think the most important one is that we have also an active React that allow you to deploy React application in iOS, in Android, and now a lot of much more systems will be supported. So you write once and deploy everywhere. This is possible also in pure JavaScript because you can use a lot of technology based on Cordova that allow these kinds of work. Okay. Mainly, I love Scala.js plus React.js because I love Scala. Because it's composed by simple concept. You have properties that are immutable. You don't change your properties of the component. You have the state that is mutable. So we have the mutable part. And we have a simple render method that do the rendering stuff. This is all React. Everything is strong typed from the VDOM to the components. So when you compile your code, you are safe that the Scala-C compiler says, okay, there is no error, your code is safe. Also easy to extend in components. Web developing in components, it's wonderful because one can be concentrated itself on a single component. It's similar to develop an application when every people thinks at actor level. In Scala React, you think about component. For example, this is a fragment of JavaScript code. We use React. We create a variable object that is a hello message with a variable display name, hello message, with a render function that render a div with your hello and your property name. When we have the render command that take a mount point, for example, a node by ID or jQuery selector and so on, and put your code. In Scala, the same code is much more compact. We have the same functionality, but we write them in a complete type-safe way. We have the val definition. We have the component that take a string. The component will be called hello message. We have a render function that take a name and render a div. Then we have a build. This is all. So develop components is very easy. We have string-typed component because if I put, when I create the object, not a string, but for example, a hint, the compilation broke and your code will not be delivered. Also, Scala.js provide also many extra. For example, Scala support. Scala was very easy to port to Scala.js. Scala.js support every kind of code that is easy write in Scala can be automatically translated in Scala.js. So Scala was ported to Scala.js very fast. Shapeless from 2.2 will be released in also for Scala.js. Also lens support. Lens for changing nested case class. Lens support monocle allow you to create a lens on case class to reduce the bulk rate in working on nested case class. Testing support is very important because without testing we are out. Testing is very easy. We can create a simulation. We can call methods typically HTML method focus click on. We create a event and the simulation run. Also, there is extra modules that provide a lot of facilities to create advanced components. For example, a router. We talk about AngularJS router. No, we have also router for Scala.js React. Router in Scala.js React are fully type safe. So you cannot write a route that is not valid. Also provide you component mixin for extending traditional component with broadcast and listener. We talk about our web page. When we talk about a web page, for example, when we talk about web pages, we have different components on the page. We have the top bar, we have a sidebar, we have the main component. So you need something that allows you to communicate with this component. The typical example is using broadcast to send from a component to another component message. This is available because you can create a similar HA system on your client, and so use reactive variables to change state in different components, sending a traditional message to your message broker. Other important extra are time components that allow you to extend with a set interval handler. So the system is able to register a callback that refresh the page every 5 seconds and so on. Also, I see another important aspect in React is the ability to detect when a component is displayed on the page. When the page, the component will be displayed, the did mount is called. The did mount initialize your component. When your component will be removed from the page, the component unmount will be called. This is important because when you register callback in your pages, they typically run, if you don't remove them from the callback spool, they always are recalled every time. External vars allow you to use lens. We talked about previously to use lens in your code to change the state of variable outside your component and propagate the change. Okay. We talk about writing HTML components, complex web application with React and Bootstrap. They are the main famous web browser frameworks. Also, from starting from the last month, there is also Scala CSS. Scala CSS allows you to create type-safe CSS for your pages. This is when you create a complex CSS, you have a lot of problems because you have to create, for example, complex constraints for the visualization of your elements. Also, you need to check in your HTML page that the CSS is correctly used, and so on. Scala CSS helps you to create a complex CSS by a type-safe way. So you can create CSS, change them, using them, and maintain them. For people that are now doing web development, they think CSS is not so important, but for now CSS is such important as JavaScript because everything is controlled by CSS in today's web application. Also, a good part is you can check the correctness of your CSS. The correct of CSS is not available in other system. There are some line tools for CSS, but the correctness that if you define constraints on them is not possible to be validated. Okay. Scala CSS generates for you the CSS given a definition. So it's wonderful because you can create standalone CSS, classical file that is served from statical resource. Also, allow you to embed in the single tags the CSS. Depends of the people and the way they prefer to develop. Okay. Now I show you some project that are available on Scala.js. The main important part of Scala.js is that you must think that you are writing Scala code. There is no difference from the Scala code that you write for your web and for the server side. So you reduce the amount of code that must be written. Also, you master a lot of I give some reference. For example, a good start point is the SPA tutorial. the SPA tutorial. The SPA tutorial is a tutorial that was written to show you how to create complex single-page application. We have every kinds of feature, for example, managing menu, dashboard, CSS, integration with other JavaScript library, for example, Bootstrap or other frameworks, using AutoWire with different. The author uses Boopickle, that is typically is custom binary serializer. Also help you to write server-side code because explain you how to write the server-side part. Okay. Other important resources are the project pages when they are very detailed and explain you how to use, for example, AutoWire, Scala.js, and so on. For big application, Quirky is a big application developed with Scala.js, mainly using jQuery and Bootstrap. Then another important part of the Scala ecosystem are the faked, because how is it possible that you use JavaScript library in your today code? You need the type signature of the JavaScript library, because the compiler must know that you are using a int, you are calling a render function that takes string and other kinds of type. This is done using the faked. The faked from the common library, Bootstrap, Metal UI, and other, are available on GitHub, so everyone can use them. For example, here there are a lot of components. They use Material UI, Google Maps. All this code is done completely in Scala.js. So talking it's not so easy, but when you use it, you feel the difference in programming it. For example, using case class traditionally, and also this is the API for map. Everything is done. Also, there are a lot of components. Using Metal UI interface and so on. There are also for Bootstrap and so on. For example, we talked previously about the SPA tutorial. The SPA tutorial showed this kind of application built in Scala.js with Bootstrap model. Providing also internal logging for action. You have JavaScript log for JavaScript that is similar to log4j, or similar to the standard library of logging in Scala, when you have a logger and you have a logger and you send messages. Okay. Talking about AutoWire, okay, we talk about the importance of packets. Also, we will see you later. We have also some tricks to create packet for well-known JavaScript library. Other project allow you to integrate Scala.js with Play frameworks, so you can use Play framework as backend and Scala.js for the front end. I suggest everyone to join the Jitter Scala.js channel, so you can have help if you need. Some tricks are that you can, now I show you some tricks very fast because we have very few time. We see the trick of Scala.js is to have the signature or your JavaScript code. But there are a huge amount of JavaScript library around the world. If you need to integrate a particular library, you need to create a facet. You have two ways. The hard way, the very easy way, search on GitHub, there is the facet, you add the dependency, you are safe. Also, you need to write the facet. The facet is the signature or your JavaScript code written in Scala. So the compiler is able to understand if you are doing the right things. JS native means that this call is not managed from your compiled code, but from the JavaScript part. And these are is a part of the jQuery facet that show you, for example, the add class, the after methods that are typically available in JavaScript. So in Scala.js code, use, for example, this facet in this way. That is similar, very similar to JavaScript 1. Also, there is a trick that you can navigate the TypeScript definition language, and there is an application that converts TypeScript typed library to Scala.js library. So you have a lot of library already typed. There are about 900 libraries that have the type signature. The library Donna, you have the signature, and the signature can be translated in Scala.js facet, so it can be used. For everyone, I suggest you to have some time and see the Scala.js page and read the hands-on Scala.js. This is explain you why also because it's wonderful Scala.js for web developing. A lot of tricks, a lot of information, low-level information if everyone wants to study and improve the knowledge of Scala.js. We have already seen this kind of information. Okay. Okay. There are some questions.
We see in the after party if you will go there or where? Where? Yeah, is Freda. He's okay. We go together. We go all together anyway. He's here around here, and thanks for coming anyway. And we'll see hopefully next year.